Thank you. The good news, by the way, is that bang was translated into American, so you'll be able to understand it. Hopefully you'll do without the simultaneous translation for my talk. What I want to tell you about is really a story of how we make discoveries and how we learn about the universe through discovering the unexpected. And for me, that's always been my dream. I started as a scientist, not as somebody looking through a textbook, but as a small kid with a small telescope, dreaming of discovering an exciting comet, especially a comet because you get to name them after yourself, or an asteroid or anything. I didn't really get very far. The closest I got, if we go to the, yep, there we go. The closest I got was this thing. I was looking one evening at an object called the Orion Nebula. It's the nearest stellar nursery to our sun, a place where stars like the sun are being born even today. And it looks beautiful in a telescope, even the small one that I had. But I nudged the telescope and this swam into view, this beautiful cluster of stars that really struck me. And I pulled out a sky atlas, a map of the heavens, and the cluster wasn't there. And so I got out a pencil and I marked it and I called it Lintott 1. It's actually known as NGC 1981. It was discovered in the 18th century. But for a brief moment, I thought I had a discovery. And I want all of you to call it Lintott 1 from now on, please, if it comes up in conversation. But yeah, this was my youthful dream. And I realized that astronomy doesn't work like that anymore. 100 years ago, you would have got away with studying a single object. This is a sketch of the Whirlpool galaxy, a vast system of stars that was the result of a huge amount of work back in the 19th century. But these days, we don't study single galaxies. We do surveys of the heavens. And so instead of studying a galaxy like this is our view of the local universe. And we're starting here on the Milky Way and flying out through something called the Sloan Digital Sky Survey, a survey of 1 million galaxies. And these galaxies, as you see them here, are in their real positions in the universe. So this isn't just CGI, this is a map. And what you can see as we get out into the distant universe is this really remarkable thing, which is that the universe is lumpy. There's places where there are lots of galaxies, and there are places where there are very few galaxies. You can really see this cosmic web structure when we get out to this distant vista of the universe. You can see, we'll stop in a minute and I'll rotate the universe for you, no expense spared. And you'll get this real sense of a honeycomb structure. And that structure is what we'd like to explain. In studying the universe, we want to find out how we ended up with this lumpy universe. Now, it will rotate in a second, and you'll see there's a sort of bow tie shape in the image. Don't worry about that. The gaps in the bow tie are the equivalent of "here be dragons." They're the bit of the maps we haven't filled in yet. But nonetheless, we have this beautiful map of the universe. Now, the only problem is that if we want to understand how we came to get that universe, we have to look at each of the 1 million galaxies that we have images of individually. We have to explain why some of them are big balls of stars, like the elliptical over here, and why some of them are beautiful spiral galaxies, like the one over here. This is a fundamental question that we'd like to understand. But recognizing the shapes of galaxies turns out to be a fundamentally human task. This is something that computers are terrible at, but humans are very good at. It's easy for you to distinguish elliptical and spiral galaxies. Now, when we only had a few hundred galaxies, that's easy. I could do that, a professor could do that, we could sit and spend our valuable time looking at galaxies. But when you have 1 million galaxies, it's not so easy. We tried getting a student to look at 1 million galaxies. The student's name was Kevin, and the first result of Kevin's thesis was that a student will look at about 50,000 galaxies before he tells you where to stick the rest of them. And so that's not a solution. And so back in 2007, I asked for 20 more students, but that didn't work either. And so we asked for help, and we created a website called Galaxy Zoo. This is what it looks like today. And it's one of the few things that lives up to its branding. Few have witnessed what you're about to see. We're actually, if you go to Galaxy Zoo today, we've just released some new images, you will see an image of a galaxy that literally no one in history has ever seen before. It's a remarkable thing to do in your everyday life. And we had huge numbers of people taking part. More than 500,000 people have now taken part in our citizen science projects. And in Galaxy Zoo alone, we've had 250,000 classifications of galaxies. And taken collectively, the accuracy of those classifications is much better than computers, it's much better than Kevin, and it's much better than professional astronomers. So we've solved this problem. We can pay attention to each of our galaxies. And when you do that, when you have individual humans looking at individual images of individual galaxies, some remarkable things happen. So here's a typical human. This is Brian May, who is an astronomer, incidentally. He studies dust in the solar system when he's not prancing about on the roof of Buckingham Palace, as you see him here. He's the guitarist from Queen in his everyday life. But Brian is a big fan of Galaxy Zoo. And he wrote on his website that everyone should take a look at our galaxies. And one of the people who did was Hanny van Arkel. She's a Dutch school teacher, and she was the first person in history to see this image. Now, there's a galaxy there, yes, 2 of them in fact, but what Hanny did was that very human thing of getting distracted by the unusual. And so she looked at this image and wanted to know what the blue blob there was. Here's a more detailed view from the Hubble Space Telescope. It's green, but don't worry about the color change. Looks like a slightly demented Kermit the Frog. Slightly evil Kermit, I always think. And Hanny called this object a voorwerp, which we thought was a technical term, so we adopted it. It's now in the literature. Turns out it's Dutch, and it means thingy. Yeah, this is now it's a 1 in a million object. It's a giant gas cloud zapped by a jet that comes from the center of the nearby galaxy, heated to 50,000 degrees. And because this was exciting, we got a Hubble Space Telescope image of it. Other people wanted their own voorwerpen, and they went out and found a whole variety of these gas clouds that have been zapped by jets. Now, we've got Hubble Space Telescope images of lots of these, and they're new images that we're still working on, so I can't show them to you. We don't want them to get out, and I wish I could tell you how beautiful and exciting these images are, but, I'm just not allowed to show you these proprietary data. Of course, some are more exciting than others, and so I have to be really careful with some of them. But the point is, these are individual objects, discoveries, the equivalent of Lintott 1, but real. Each of these images has a person behind it who said, you should take a look at this. And we don't have to restrict ourselves to galaxies either. We launched a site called Planet Hunters a few years ago, which again does what it says on the tin. With your help, we're looking for planets around other stars. It's a sort of no planets left behind program. We want to make sure that in studying the exoplanets that we've heard about already, we don't want to miss any, we don't want the computers to make a mistake, we don't want the professionals to let interesting worlds slip through our fingers. And so Planet Hunters is an experiment to help us look for planets. You've already heard about how we might do that by looking at the effect of the planet on its star as it orbits. Now, we found about 100 candidate planets that had been missed by the professionals. More than 40 of them are in what's called the habitable zone, that region that's not too hot and not too cold, but might have liquid water. But this is my favorite. This is what we think it might look like to be on a moon orbiting a world now called Planet Hunters 1b, which is a terrible name for an exciting place. Planet Hunters 1b is the only planet that we know of in a system with 4 stars. So you have 2 stars going around each other, the planet orbits both of those stars, and then there's another 2 stars over here, and the whole lot orbits in this cosmic dance. Now, we didn't know that planets could form in that environment. We didn't know to look for planets in such complicated systems. But there it is, there's Planet Hunters 1b. Well, there's an image, there's a drawing of it anyway, but we know it's real, and it's telling us something about how planets form, trying to unravel the mystery of how our solar system formed. And it was found because of the efforts of the hundreds of thousands of people who've taken part in Planet Hunters. I don't have time to list them all, you'll be glad to know, but here's an example. This is Roy Jackson, who's a retired police officer from the north of England, and he was a discoverer of Planet Hunters 2b, our second confirmed planet, which is a Neptune-sized world in that beautiful Goldilocks zone, that habitable zone that's the right temperature. And Roy, he's a very prosaic man. He was asked why he took up planet hunting. And he said to the newspapers, he said, well, there's only so much gardening you can do, which I think is a profound and fundamental truth. But but he's there to remind me to say that the people who take part in our projects aren't well, they are scientists, they're doing science, but they aren't professional scientists. They don't have degrees in science. They're not even necessarily amateur astronomers with a deep knowledge of the skies and the heavens. These are just people who got bored on their lunch break, who had a spare few minutes to log on to one of our sites and make a difference to science. And we're going to need that help more and more, because this is what the future looks like. This is my vision of what's going to happen to astronomers in the next few years. We have the robots taking over. We've got very good at building robots that can take images and acquire data about our universe. Let me correct the picture to make it more scientific. There we go. This is the Large Synoptic Survey Telescope. This is as big. It's a real thing. It's being built right now. The mountaintop in Chile has been leveled to prepare for it. This telescope's as big as the largest telescopes in the world today, but it's a survey telescope. It's going to scan the whole sky every few minutes. And and that data is going to go straight onto the web for everyone to share. And if we take a conservative estimate, let's just say we care about the things that change from night to night, one small piece of the scientific legacy that LSST will create. Well, a conservative estimate is that we'll get 250,000 alerts a night that something has changed. That might be asteroids moving in our solar system, it might be a comet on its way in, it might be a star flickering because a planet got in its way, or it might even be the nucleus of a nearby galaxy flickering as material falls down towards its central black hole. It's going to give us a completely new vision of the sky, but it's also going to overwhelm professional astronomers. We're going to find so many interesting and unusual things that our only hope is to build a community of people, hundreds of thousands strong, each of them contributing a few spare minutes every now and then to help us deal with this flood of data and to really get to do the job we need to do in converting data, the raw material that comes from the telescope, into knowledge about the universe. And so my vision of the future of science looks something like this. It's not somebody sitting in a laboratory, it's not somebody in an important academic gown and a hat doing complicated mathematics on a blackboard. It's a group of people enthusiastically working together to try and make a discovery or two. And if you do make a discovery, I'm happy to bribe somebody to name it after me as well. Thank you very much.